So what is coupling? Coupling refer to the degree of dependency between the classes or the modules, right? Degree of dependency, like how much one class is dependent on the other. Okay, so there are two types: tight coupling, loose coupling. What is tight coupling? The classes are highly dependent on each other, right? That means this is the bad practice, right? Classes are highly dependent. That means if we change one class, it will affect the other class also, right? What is loose coupling? These are independent and communicate through the abstraction or interfaces, right? Classes are independent of each other. So this is the best practice, loose coupling, right? Let's see the example. Tight coupling. What is the definition? We are already seen. The class is tightly coupled to another when it directly create or depend heavily on the class implementation. Let's take the example. We are having one class engine, right? We are having the method start, engine started, correct? Now we are having different class, car class, right, which is having the object of engine. This is what? This is tight coupling. How? I will explain it. And again we are having one method start car, in which we are calling the method of engine start. This one, got it? Now how this is tight coupled? See, what is the problem? Car is dependent on the concrete class engine. If we change the engine class, car must be changed too. Let's say here we are having simple engine. In the future we are having one petrol engine, right? So again we need to create it, right? And again add it here, right? Add it here. Our car is having petrol engine. Now we need to change this class also and this class also. That means this is the tight coupled. Got it? Car class is dependent on the engine, right? If we change this engine class, then we need to change our car class also. So this is the example of tight coupling. Now what is loose coupling? Now here comes the violation. It violates the open close principle. There are some principles, solid principles, right? And here O refers to open and close. That means what is open and close principle? We will cover these principles in the upcoming sessions, right? What is basically this open and close principle? It states our class should be open to extension, right, but close to what? Modification, right? And here it violates. We are modifying our class, got it? So this is the violation, open and close principle. So here comes loose coupling. This is the good practice. What is the definition? Means reducing dependency between the components so that changes in one do not affect others. Got it? Reducing the dependency. How we can achieve? Using interfaces, using dependency injection, using inversion of control. Got it? Let's take the example. What is the example? So here we are using the interface. Instead of having a class engine, we are having the interface. Interface what? Engine, which is having a start method, right? Correct. Now in the car class we are having the reference of this engine, and when we are creating the object of this car class, we are passing the object of engine. This is what? This is constructor dependent injection. That is the type of dependency injection. So there are three types, that is setter injection and this constructor injection. One more is there, I think, field injection. Okay, so that is the part of Spring Boot. Got it? So here this is the constructor injection. Means we are basically injecting the dependency using the constructor. Okay, in the main function. Now when we are creating the object of car, we will pass the object of engine, right? Now here currently we are having this petrol engine, right? Petrol engine implements the engine, and we are having the definition of the start function. Okay, so we will be passing the petrol engine and we will get the system.out.println, that is petrol engine started. Correct. Now in the future, let's say we have the diesel engine. Okay, diesel engine. Now what we will do, we will simply create one more class, right? This is the petrol class. We will create a diesel engine class which will implement the same engine interface. We will be having, let's say it is printing diesel engine started. Correct, started. So now are we changing something in this car class? No, we are not changing. In the main function, while creating this object, now we will pass what? New car diesel engine. Got it? We will create the object of diesel engine and simply pass it. Using constructor injection, it will get the diesel engine and call this start function of the diesel engine. We will get this output. Got it? So here we are not changing anything in this car class. That means they are loosely coupled. Tight coupled is clear for all. So the last part is clear, right? This part is clear. Why this is tightly coupled, right? We are having the engine class and we are having the car class. Now if we are creating new engine, that is petrol engine, then we need to modify both engine class also as well as the car class also, right? Now how we can modify this to loosely coupled? That means if we modify to this, let's say if we are adding this petrol engine, we need not to change car class. How we can do this? Using interfaces. How? So tight coupled is clear, right? We are if we are adding new engine, that is petrol engine, then we need to modify engine class also as well as our car class also, right? But here how we can make it loosely coupled? We will use the interfaces. Okay, interfaces. Instead of this engine class, we will use the interface. Correct, interface. And we are having one class, that is what we are having, this petrol engine, right? Petrol engine is there. Correct. Now in the future, if we want to have diesel engine also, what we will do? We will create a new class, right? Diesel engine, which will implement this interface, right? Same as this, we will be having class diesel engine implement this interface engine, and we will give the definition of this start method. Okay, start. We will give some definition. Correct. This part is clear, right? How we are adding this new class, that is diesel engine. Got it? We are just adding new class and implementing this interface. Clear, right? So basically interfaces is what? In the interfaces we will be having the 100% abstraction. What is abstraction? That means showing the necessary things and hiding the unnecessary things. That means we are just showing the name of this method, right? After that, whichever class is implementing this will give the definition. Till this point is clear how we are creating this diesel engine using the interface. So we know how we are creating this diesel engine. Now in the car class, what we are doing? Let's check this car class. We are having this definition of the engine, right? And we are having this constructor of the car, right? Let's say in the main function, this is the main function, right? So we are creating the engine, right? And then we are creating the engine of petrol, right? New petrol engine. Correct. So okay, so this is how we will create the object of petrol engine, right? We are having the, this is what? This was the interface, right? And this is the class that is implementing the interface. So we can create class, right? That is the type of engine only. Got it? This petrol engine is a type of this interface, that is engine. So this is how we will create the object of petrol engine. Understood? After that, what we are doing? We are creating the new object of car class, and we are putting this, let's say this is petrol P engine. Okay, P engine. Got it? Now here what is happening? This is basically constructor injection. We are injecting the dependencies. That means engine is the dependency. Okay, and we are having the constructor. We pass this object. Got it? Now this dot engine equal to engine. We covered this keyword yesterday, right? So we got the instance of this engine, right? Now what's next? We are having the start car, and we are calling this engine dot start. Now this is the type of the object, right? So it will call this method. So now we are having the instance of this petrol class, right? Now in the future, let's say we are having what? We are having one diesel engine. So this is how we will create, right? We will be using this interface engine and create the class, that is diesel engine. Provide the output. Okay, the system dot, basically the definition of the method. Got it? Now do we need to change anything in this car class? Do we need to change anything? No. We will just change in the main method. How? Now we will create engine. This is the interface, right? D engine, okay, equal to new object of what? This diesel engine, right? Diesel engine, and we will create the new object of car. Pass this D engine, and everything will be same here, right? Now we will get what? We will get the instance of diesel engine, and it will call the start function of diesel engine, which we provided the definition in diesel engine, right? Got it? So we are not changing anything in this car class. Okay, so this loose coupling is clear for all, right? Now what is the benefit? Now you can replace petrol engine with the diesel engine, electric engine, without changing the car, right? We just need to create new class, right? New class that will be implementing what? The engine interface, right? This is the first thing. Second thing we will do, create object of that new class in the main function and pass it. Main function and pass it in the car object. That's it. We need not to change anything in the car. This is what? Loose coupling, right? So this is a task for you to try. Okay, just make a main function, okay, and then just try to create new class that will be implementing this engine interface. Okay, this will be the task for you guys, and it follows this open and close principle that says open for extension. We are creating new class, right? We are extending it, and close. What is close? Close for modification. We are not modifying this car class. Okay, so that's it. This is the diagram. In the tight coupling, we are having the direct dependency. Here in the loose coupling, we are having the engine, and we are creating new classes accordingly. So this is clear. Let's move to the next part.